We're all a little obsessed with the weather, right? We check it every single day. But have you ever stopped to think about what's really driving it? Today we're going to pull back the curtain and see what's pulling the strings behind everything from a perfect sunny day to a wild snowstorm.
But first, let me throw a puzzle at you. How in the world is it possible to be chillin' on a warm, sunny beach and at the same time see a snow-capped mountain just a few miles away? How can two spots so close together have such crazy different weather? Well, let's solve that mystery together. Okay, let's dive right in. The very first clue to solving our puzzle is getting our heads around a really important difference. The difference between the atmosphere's mood and its personality. Here's a super easy way to think about it. Weather is basically the atmosphere's mood. Right now, is it sunny? Is it rainy? Is it windy? That's what's happening this very second. Climate, though, that's its long-term personality. It's the pattern of weather you can pretty much expect over years and years. A place's climate is why you know to pack a swimsuit for a trip to the Caribbean and not, a giant parka.
And this is the perfect way to see it in action. On the left, you've got a daily weather map. That's a snapshot, right? A momentary mood. But on the right, you see palm trees. And palm trees can only grow and thrive in a place that is warm consistently over the long haul. That's not a mood. That's a personality. That's climate.
So, if climate is the personality, what shapes it? What are the big forces making it happen? Let's get to our first major driver. And honestly, it all starts with our planet's relationship with the sun. It sounds almost too simple, but this is a hugely powerful idea. You see, pretty much every bit of temperature on our planet, from the poles to the equator, starts with one simple thing: the angle at which the sun's rays hit the ground. Take a look at this. Near the equator, the sun is basically right overhead. Its rays hit the Earth like a focused flashlight beam, delivering super concentrated heat. But as you move up toward the poles, those same rays come in at a really shallow angle. It's like tilting the flashlight. The same amount of energy gets spread out over a much bigger area, and that just means less heat for any one spot. And the impact of this is just massive. It literally dictates where life can exist on Earth. You get animals like this Egyptian lynx, perfectly built for the hot, dry places where the sun's energy is super intense. And then at the complete other end of the spectrum, you have polar bears, built for the freezing cold polar zones where that energy is so spread out. But hang on, the sun's angle can't be the whole story, right? There are two other key things that fine-tune the temperature right where you are. They help explain why things can get higher, colder, and even windier. So the first factor is altitude. It's a simple idea we've all heard of. It's just how high up a place is from sea level. But wow, its effect on temperature is huge. And this is exactly why we get snow on mountains even in the summer. As you go higher up, the air expands and it gets less dense. Those little air particles have way more room to spread out, so they slow down and the air gets colder. So the key takeaway is, you go up, the temperature goes down. But it's not just about how high you go. Back down near sea level, there's another giant player in the game: water. Water plays this enormous role in keeping temperatures from getting too extreme, especially for places near the coast. So here's why. Water has something called a high specific heat. Think of it like a giant thermal battery. It takes a really long time to heat up, but once it's warm, it takes a really long time to cool down. Land is the complete opposite. It heats up super fast and it cools down super fast. This difference is what creates local winds like sea breezes, and it's why coastal areas are usually more mild all year round. Okay, so we've got a good handle on temperature, but there's another, completely invisible force that shapes our weather every single day. Let's talk about something that might sound a little weird: the weight of the air. It sounds a little crazy, doesn't it? What if I told you that the air all around us isn't weightless at all? That it has real, actual mass, and it's pushing down on you right now with a whole lot of force? Don't believe me? We can actually prove it with a really simple experiment. So you balance two identical, inflated balloons on a rod until it's perfectly level. Then, you pop one. Instantly, the rod tips down on the side with the full balloon. The only difference is the air inside. That air has weight. And we can even see the force of this weight, which we call atmospheric pressure. Check out this classic experiment. You drop a burning piece of paper into a bottle and stick a boiled egg on top. As that air inside cools down, the pressure inside plummets. The much, much higher pressure of the air outside the bottle then does something incredible. It literally shoves the egg right into the bottle. So, after seeing that, what is atmospheric pressure, really? Well, it's the weight of an entire column of air stretching from the very top of our atmosphere all the way down to the ground, pressing on every single square meter. And believe me, that adds up to a lot of weight. Okay, so we've tackled temperature, we've tackled pressure, we have all the clues. Now it's time to put all the pieces of the puzzle together and see the full picture.
So let's connect all the dots. We've seen that temperature is really a mix of three main things: your latitude, where you are on the globe; your altitude, how high up you are; and how close you are to a big body of water. And at the very same time, that invisible force, atmospheric pressure, is being affected by altitude, by temperature, and even by humidity. All of these things are constantly working together.
And that brings us right back to our original mystery. The beach and the mountain. Why are they so different? It's because the weather in any one place is the result of a totally unique combination of all these powerful forces. The beach is at a low altitude, and its temperature is being moderated by that nearby water. The mountain is at a super high altitude, where the air is thinner, less dense, and much, much colder. Same region, completely different weather. Mystery solved.
We've seen just how incredibly interconnected all these systems are. The sun's angle, the altitude, the pressure, the temperature, they're all in this constant dance together to create our weather. And that leaves us with one final, really big question to think about. If all these natural systems are so finely balanced and connected, what happens when we introduce large-scale changes to our planet's temperature? How might that affect this incredible dance?